Hello everyone. In today's lecture, we will see some more practice questions based on applications of derivatives. So let's start. In the last lecture we had done till question number 12. Now from this lecture we will start from question number 13. We will do from question number 13 to 16. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So let's start with question number 13, which says if y is equal to fx is the equation of a parabola which is touched by the line y is equal to x at the point where x equal to 1, then which option is correct? So the hint of this question is C. We are given a curve y equal to fx, which is the equation of parabola, right? And the line y equal to x touches this parabola at x equal to 1, clear? Right? That is, this line y equal to x is tangent to this parabola at point x equal to 1, right? So if x equal to 1, then y will be also 1, right? Because it is lying on the line y equal to x, right? So in this way, we can approach this question. We can write the tangent. First, we will write the equation of parabola in quadratic form, clear? And we can find different coefficients attached with the equation, okay? So in this way, we can solve this question. You have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Here y is equal to ax square plus bx plus c, right? It is equation of parabola, right? As it touches y is equal to x at x equal to 1, therefore, when you will put x equal to 1, you will get y is equal to a plus b plus c. And c, if x equal to 1, y will also be equal to 1 because y equal to x, right? Therefore, a plus b plus c is equal to 1. Now, dy by dx is equal to 2ax plus b, right? Therefore, dy by dx at x equal to 1 is equal to 2a plus b. Therefore, 2a plus b is equal to 1, right? Now, from y equal to x, slope is equal to 1, right? Because y equal to mx plus c, slope is equal to 1. Now, fx is equal to ax square plus bx plus c. Therefore, f dash x is equal to 2ax plus b, right? And f double dash x is equal to 2a. Now, since f0 is equal to c, if we put x equal to 0, we will get f0 is equal to c, right? Therefore, f0 is equal to c. So, f dash 0 is equal to b. F dash 0, because f dash x is equal to 2ax plus c. When you will put x equal to 0, you will get f dash 0 is equal to b. Now, f double dash x. See, f double dash x is independent of x. Therefore, f double dash 0 will be equal to 2. Clear? Now, we have to find basically now see, f dash 1 is equal to 2a plus b. Clear? 2a plus b. F dash 1 is equal to 2a plus b. Got it? And 2a plus b is equal to 1 as from this equation. Clear? Right? So f dash 1 is equal to 1 is the right answer. Right? F dash 1 is equal to 1. It is the right answer. Okay? So I think option B is the right choice. F dash 1 is equal to 1. Got it? Okay, let's move to the next question. Question number 14, which says, let a plus b equal to 4 and a less than 2 and gx be a monotonically increasing function of x, then fx is equal to integration of 0 to a gx dx plus integration of 0 to b gx dx. Then which option is correct? Fx increases with increase in b minus a or decreases with increase in b minus a. We have to find increase or decrease of fx with respect to b minus a, right? So the hint of this question is C. We have given a plus b equal to 4 and we have given the relation a less than 2. and gx be a monotonically increasing function of x, right? And fx is given as this. Now see, we have to discuss the increasing and decreasing of the function fx, right? Therefore, f dash x can be found by taking derivative of fx throughout left hand side and right hand side, clear? And after we will take derivative, that is f dash x, we will see whether f dash x is greater than 0 or less than 0 by using these two conditions, that is a plus b equal to 4 and a less than 2. And also this condition gx be a monotonically increasing function of x, that means g dash x should be greater than 0, right? G dash x should be greater than 0. So by using these three conditions, we can easily find whether fx is increasing or decreasing in b minus a, right? So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part. See, since a plus b is equal to 4, therefore b is equal to 4 minus a, right? And b minus a is equal to 4 minus 2a. Here, b minus a can be written as 4 minus 2a. Suppose it is equal to t. Now, let's calculate integration of 0 to a gx dx plus integration of 0 to b gx dx is equal to integration of 0 to a gx dx plus integration of 0 to 4 minus a gx dx is equal to ia. Suppose it is equal to ia. Now, d of ia upon dA is equal to ga minus u of 4 minus a, right? U of 4 minus a. Got it? Now, as a less than 2 and gx is increasing, a less than 2 and gx is increasing, since gx is increasing, therefore, if 4 minus c, a is less than 2, therefore 4 minus a will be greater than a, right? Clear? You can easily see 4 minus a will be greater than a. Therefore, ga minus g4 minus a less than 0. Ga minus g4 minus a less than 0 because gx is increasing function, clear? That is, if 4 minus a greater than a, that means g minus a, g of 4 minus a will be greater than ga, right? Therefore, d of ia upon dA less than 0. D of ia upon dA is less than 0. Now, d of ia upon dA is equal to d of ia upon dt into dt upon dx, right? See, t is equal to 4 minus 2a, right? So, therefore, dt upon dx will be minus 2, isn't it? dt upon dx, dt upon dA will be minus 2, right? Therefore, see, dt upon dA can be written as minus 2. Therefore, dia upon dA can be written as minus 2 into dia upon dt. Therefore, dia upon dt is greater than 0. Thus, ia is an increasing function of t. Hence, the given expression increasing with b minus a, right? Clear? Therefore, given expression ia is an increasing function of t. Hence, the given expression increasing with b minus a. Got it? Right? So I think increases with increase or in b minus a, option A is the right choice. Increases with increase in b minus a. Right? Okay, let's move to the next question. Question number 15, which says the angle of intersection of curves y is equal to greatest integer function of mod sin x plus mod cos x and x square plus y square is equal to 5, where greatest integer function denotes where this box denotes the greatest integral function, right? Okay. So see, the hint of this question is we know that mod sin x plus mod cos x is basically pi by 2, right? Pi by 2, isn't it? So this thing, greatest integer function of mod sin x plus mod cos x and x square plus y square equal to 5. The angle of intersection of this curve. So the one curve is y is equal to, suppose greatest integer function of this is pi by 2. Yes, this is pi by 2. Greatest integer function of pi by 2. And one curve is x square plus y square equal to 5. Clear? So we will find slope of this curve. Slope of this curve and slope of this curve. The angle of intersection of the slope of this curve will be equal to angle of intersection of that of both the curves, right? Okay. So in this x square plus y square equal to 4, you can calculate dy by dx by differentiating both sides throughout. You will get dy by dx, that means slope. So y is equal to greatest integer function of mod sin x plus mod cos x. In this, you will get dy by dx as uh, dy by dx as 0, that is horizontal line. Okay. So in this way, you can approach this question. You have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. We know that mod sin x plus mod cos x is between 1 to root 2, right? We know this. Mod sin x plus mod cos x is between 1 to 2, right? Therefore, greatest integer function of mod sin x plus mod cos x is equal to 1. 1. Initially, I told that mod sin x plus mod cos x is equal to pi by 2, which is not right, right? This will be true in case of sin inverse x plus cos inverse x, right? But here we have mod sin x plus mod cos x, which we know that is lie between 1 to root 2, right? 1 to root 2. So greatest integer function of something, some function which is between 1 to root 2 is basically 1. Let P and Q be the points of intersection of the given curves. Clearly, the given curves meet at points where y is equal to 1. Where y is equal to 1. So we get x square plus 1 is equal to 5. Therefore, x is equal to plus minus 2. Right, x is equal to plus minus 2. Got it? Now, we have 2 points, 2 and 1 and minus 2 and 1. Right, now P, 2, 1 and 2 minus 2, 1. P, 2, 1 and Q minus 2, 1. Right, minus 2, 1. Now, on differentiating this curve, x square plus y square equal to 5, with respect to x, you will get 2x plus 2y dy by dx equal to 0. Therefore, you will get dy by dx equal to minus x by y. Now, dy by dx at point 2, 1 is basically minus 2. And dy by dx at point minus 2, 1 is equal to 2. Clearly, the slope of line y is equal to 1 is 0. And the slope of tangent at y, tangent at P and Q are minus 2 and 2 respectively, right? Therefore, the angle of intersection, we can apply tan inverse. One slope is 0, 0 plus 2 upon 1 minus 0 into 2, here, which will be equal to tan inverse 2 for both the case. For when we take minus 2 as well as when we take 2. For both the case, the angle of intersection will be tan inverse 2. Okay. So I think tan inverse 2 is the right choice. So I think option C is the right choice. Tan inverse 2. Got it? Tan inverse 2 is the right. Right? Let's move to the next question. Question number 16, which says in question number 16 says that in 0 to 1, Lagrange's mean value theorem is not applicable to. So we have to see Lagrange's mean value theorem in these questions, right? So the hint of this question is C. What are the conditions of Lagrange's mean value theorem? The conditions are, first condition is the function should be differentiable in a to b. The function should be integrable in open interval a to b. Third condition is fa should be equal to fb, right? Fa should be equal to fb. No, this is the condition of Rolle's theorem. The condition of mean value theorem is first two, which is the function is continuous in a to b and function is differentiable in open a to b, right? Then there must be at least one c where f dash c is equal to fb minus fa upon b minus a, right? This is basically the Lagrange's mean value theorem. Now we have to check in which function Lagrange's mean value theorem is not applying. We will see whether this two condition is satisfying or not. Right? Here, so this was the hint of this question. Now you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay. Okay, let's move to the solution part C. there is only one option, one function option A whose critical point is 1 by 2, which is lying between 0 to 1, right? See, there must be at least one C between A to B. Here A is 0 and B is 1, right? So there must be at least one C which is between 0 to 1, right? So see, in option, there is only one critical point, 1 by 2, which is between 0 to 1. Clear? So let's first check with option 1 whether other two conditions are satisfying or not. So there is one function in option A whose critical point 1 by 2 is between 1 by 2 belongs to 0 to 1, but in other parts critical points 0 does not belong to 0 to 1. Then we can say that functions in option B, C and D are continuous on 0 to 1 and differentiable in 0 to 1. Now for fx 1 by 2 minus x when x less than 1 by 2 and 1 by 2 minus x square when x greater than equal to 1 by 2. Now let's see left hand derivative of f dash 1 by 2. F dash 1 left hand derivative of f dash, first find f dash 1 by 2, which will be minus 1, right? And f dash minus 1 when x less than 1, and 2 times 1 minus 2 times 1 by 2 minus x when x greater than equal to 1 by 2, right? Here left hand derivative of f dash 1 by 2 is minus 1, and right hand derivative of f dash 1 by 2 is 2 times 1 by 2 minus 1 by 2 into minus 1, which is 0. Therefore left hand derivative of f dash 1 by 2 not equal to right hand derivative of f dash 1 by 2. Therefore f is non-differentiable at x equal to 1 by 2, which belongs to 0 to 1, right? Therefore Lagrange mean value theorem is not applicable to fx in 0 to 1, right? Therefore Lagrange mean value theorem is not applicable to fx in 0 to 1. Clear? So I think option A is right choice. Lagrange's mean value theorem is not applicable. Clear? Yeah. Because left hand limit of f dash x is not equal to right hand limit of f dash x, right? Okay, so I think option A is the right choice. Yeah, Lagrange's mean value theorem is not applicable. Got it? So in this way, we have discussed a lot of questions based on applications of derivative. Hope you like the quality of questions you understood. Hope you understood the all concepts and techniques and tricks how to apply and how to approach this question. Okay. Hope you liked the lecture. Okay. Thank you so much.